Okay, we're trying to transfer a Cartesian equation for a curve into a polar equation. Now all we need to do for this is to remember that a Cartesian is in terms of r and theta. Sorry, a polar is in terms of r and theta. A Cartesian is in terms of x's and y's. Okay, so r cos theta will be x, and r sine theta will be y. Okay, so in order to transfer these, we just substitute these in. So going back to my curve, we've got r cos theta all squared plus r sine theta all squared, and then we're going to square the whole lot, okay, which equals 6x times y sine theta. Okay, so here we've got r squared cos squared, so here we've got r squared times cos squared theta plus sine squared theta all squared. Here we've got 3 lots of r squared times 2 sine theta cos theta. So here we've got r squared squared, which is r to the power 4, because this equals 1. And here we've got 3r squared. This is sine 2 theta. So now we can divide both sides by r squared. So we get r equals 3 sine 2 theta. Proved, or as required, or something similar. Okay, bear in mind we knew what we were looking for, so keep that in mind. Now, part B. Okay, we're trying to find the area of the shaded region. 9 marks. Okay, so at point A, we know that y, as theta increases, y stops increasing, okay, because it's a maximum point. So we know that dy by d theta, so at A, dy by d theta equals 0. Okay, and we know that y equals r sine theta. Okay, and we know that r is the square root of this. So y equals root 3 root sine 2 theta times sine theta. Okay, so y equals root 3 sine 2 theta to the half times sine theta. Now we're going to differentiate it. So dy by d theta, we can use a product rule. The root 3 obviously will be there throughout. Because we're going to make it equal to 0, the root 3 will actually disappear, but I'll put it in initially. So root 3, differentiate the first one, we get times a half sine 2 theta to the minus a half times the differential of the bracket, which is times 2 cos 2 theta times sine theta. Okay, a bit of a long-winded one, that one. So that's the differential. That square bracket is the differential of this times this one, and then plus root 3 sine 2 theta to the half times differential sine theta cos theta. Okay, so we want this to equal 0. So we end up with the root 3's can go because it's going to equal 0. The half and the 2 will obviously cancel. So I'm left with sine, off the bottom of the page, sine 2 theta to the minus a half cos 2 theta times sine theta plus sine 2 theta to the half cos theta equals 0. Now I'm going to multiply everything by sine 2 theta to the half. Alright, in order to get rid of this. Remember, this is at the bottom of fraction. I'm going to multiply by sine 2 theta to the half. Okay, so this becomes 1. So I get cos 2 theta sine theta plus sine 2 theta cos theta equals 0. Alright, so now I'm going to have to put it in all terms of sines or cosines. Because I've got a single sine here, this is 2 sine squared theta cos theta. So because I've got a sine squared, I can put that into cos squareds. Or I can put the sines, so keep going. So this is 2 cos squared theta minus 1 times sine theta. Take a factor of 2. Oh, sorry, this is wrong. This is 2 sine theta cos squared theta. Sorry. Okay, so because sine 2 theta is 2 sine theta cos theta, so we get this. Take a factor of sine theta out. 2 cos squared, take away 1 plus 2 cos squared, so that's 4 cos squared theta minus 1. So that implies sine theta equals 0, or cos theta equals square root of a quarter, so a half, or cos theta equals minus a half. Theta equals 0, which is of no interest to us because it's the point at the bottom, so it's here effectively. This is theta equals pi by 3, and cosine can't be negative in the range 0 to pi by 2, so it's no solution. No solution. Okay, so what we're trying to do after all that. So I found theta, so I know, let's go back to do a separate page. So I've got, let's do another diagram. Beautiful diagram. Alright, so I'm interested at the top here. I know this angle here is pi by 3. Okay, so what I'm going to be doing, I've got a triangle here, and I've got an area, and so I'm going to find this and take it away from the triangle. Okay, that's my plan anyway. Let's have a go. So I know that theta is pi by 3 here, and I know theta is pi by 2 here. Okay, do I know what the value of r is? Do I care? So the area is a half the integral of r squared d theta, and I know theta is going from pi by 2 to pi by 3, and that's the shaded area. I know that r squared from earlier equals, from right at the beginning, from part A, I've got r squared is 3 sine 2 theta. So it's half the integral 3 sine 2 theta d theta. Okay, so that equals, I've got 3 over 2, which I can take the 3 out. The integral of sine 2 theta is minus cos 2 theta over 2. that's between pi by 2 and pi by 3. Put it there. Okay, so we're left with minus 3/4 times cos 2 theta cos pi, take away cos 2 pi by 3, which is minus 3/4 times minus 1 plus a half, which equals 3/8. And finally, I need to find the area of the triangle. So the area of the triangle is half base times height, which is a half times r cos theta times r sin theta, which is a half r squared cos theta sin theta, which is which equals a half r squared from earlier is 3 sin 2 theta times cos theta sin theta, which is half times 3 times sin 2 theta times a half sin 2 theta, which is 3/4 sin squared 2 theta. We know theta is pi by 3 in the diagram, so because here is the x, here is the y, this is the angle pi by 3, so we end up with 3/4 sin squared 2 pi by 3, because we're doubling the angle, which equals, do it on a calculator, but it's just 9/16, 3/4 times 3/4, which is 9/16. So we're left finally, after all that, the shaded area in question, not in our diagram at the top, equals the triangle, which is 9/16, take away the area inside the polar curve, which was 3/8, so we're left with an answer 3/16.